Hello everyone, hope you are doing well. So today I will be explaining K-means clustering and hands-on using computer vision library. But first let's take a look at clustering. Clustering is grouping data points and creating patterns based on similarities. So it's a set of similar data points, or we can say it's a set of points that are most likely similar to each other. This clustering is a machine learning technique, and the key difference from other ML technique is that in case of clustering, we don't have a response class. So when the clustering process is completed, someone has to look at the data and then he has to make assumptions. Here we don't have a hard encoded response class. So the main goal of K-means clustering is to partition n data point into K clusters. Then these data point will be assigned a cluster with the nearest mean. So what I means through this, let us go through the algorithm first. So in the K-means clustering algorithm, first we have to define the clusters. It means into how many ways we want to classify our data. Then then the algorithm will randomly initiate K centroid. So what I mean by that, let's go over to the draw here. So let's say this is our initial data. So here we contain some red data, some this color data, some red data, and some this color data. So what we want is we want to group this data to find some patterns. Though we will be using K-means clustering, here I want this data will be divided into 3 clusters. So I have defined the value of K equal to 3. So as I mentioned, first we have to define the value of cluster, then it will randomly initiate some centroid. So I have defined the value of K equal to 3, then it will initiate 3 centroids, this one, and this one. So these are the 3 centroids, and on the basis of these 3 centroids, the mean of the whole data will be calculated, and then the whole data will be arranged as per the centroid. So over the iterations, it may be many iterations, this data will be clustered into this data. So here we can clearly see that this random data is now having 3 clusters, each clusters having its own meaning. Okay, so now let's go over the code, some real example. So as you can see, this is the data that is randomly divided into 3 clusters. We have 3 clusters, so we have 3 dimensional here. So when we have many n dimension, we have n dimensional data. So I will be using computer vision library for performing hands on this data. So let me go to the top. I am using Google Collaboratory. This will help me to run my code faster. So in these couple of lines, I am just importing the libraries that are required to do this hands-on. First is, of course, the computer vision library that is used throughout this explanation. Then I am using NumPy. So NumPy is a mathematical library that is used. It saves a lot of time for doing mathematical calculation. Then in order to display back the result to the user, I am using IamShow library. Finally, these images, these all images in which we have to use K-means clustering algorithm are stored on my Google Drive. So to load them, I have mounted my drive here. And now let's see the code. Okay, so here in the first line, I have read my image from the drive. Then I am printing the shape of image. Then I am resizing the image. My original image is 1280 in comma 3. So it's a huge image. Lot of mathematical calculations will be required to process this image. So that's why I have reduced its size to 500 into 500. Then I am printing the image back to user. So this is our image. Here we have one butterfly. We have let's say so many colors. So we will be clustering these colors. So first forget this code. I will explain it later. Here I have defined 2 clusters. So here the value of K equal to 2. So what will happen? This whole image colors will be grouped only into 2 clusters. So as we can see here, we have only 2 colors. This background and the butterfly is having a common color and the flower is having the different color. So whole image colors are clustered into only 2 colors here. if I increase the value of k to 4, which means now the number of clusters will be 4. Now this image colors will be grouped into 4 colors. So now we are having different colors. This color is 1, second is butterfly wings, third is flower, and another shade of flower. We have total of 4 colors here. Next, let's increase the value of clusters. So now we are having 6 clusters. The value of k is equal to 6. Now the whole image colors are divided into 6 clusters. Now the background and butterfly wings are of different colors now, so we have 6 shades of color. So similarly, if we increase the value of k to 9, which means now these image colors will be grouped into 9 classes, or 9 clusters or 9 categories. Now we have this much of colors. Now before going to the actual code, let's understand the parameters first. So here the first is samples. So the function that we are using here is cv2.k, means it can't accept this image as an input. So we need to pre-process that image. We need to convert into it some different data type. This is what samples here is. So here we are converting this image into np.float32 of data type. Then we are defining the numbers of cluster. It means into how many ways we want to cluster our data. The third parameter is the criteria. So this criteria is actually the termination criteria. It means when our algorithm will stop. So when this criteria is satisfied, the algorithm iteration stop. So here we are giving it 3 tuples: type, max iteration, ellipson. So we have these different 3 flags here. First is cv2.term criteria EPS. It means stop the algorithm iteration if specified accuracy, or we can say ellipson, is reached. The second is max iteration. It means stop the algorithm when the specified number of iterations are reached. And third is the combination of both this EPS, which means the accuracy, and maximum iteration. So here EPS means ellipson. So next we are using some flags. So these flags are used to actually initialize the centroids point. So these flags are cv2.k, means pp centers, and random centers. So here random center means the algorithm will automatically defines the initial starting points. We no need to intervene. So now let's go to the code actual. This is the code. Z is equal to img.reshape -1, 3. Here we are reshaping our image into a 3-dimensional array. Here this -1 is unknown variable. NumPy take care of it. When we are converting our image from original image to NumPy, then we have to specify this criteria. So NumPy will fill it out. And here 3 means we are converting our image to a 3-dimensional array. Then np2.float32, we are converting this data to np.float32 type. Then I have explained the criteria, when the algorithm will stop working, when the algorithm will finish actually. So criteria, I am using both the criteria, EPS, which means accuracy, and max iteration. Here EPS, the maximum number of iterations are 10 and accuracy is 100%. Now the next is k equal to 9, which means how many clusters. So we are defining here the 9 clusters. Then this is the function that I'm using to classify or divide this data into clusters. The function is cv2.k means. So let's take a look at these clusters. So this cluster takes first, this is a built-in computer vision function. Z, we are giving it this image, then the number of clusters, ignore this none. Then we are defining the criteria, this criteria that we have defined here, the number of clusters, and finally how it will choose the random centers. So we have defined the random centers. At this step, our clustering will get performed, and then in order to show the image back to the user, as you can see here, I have converted my image to float 32 data type, but I want it back to the original so that we can see it. So here I am converting my image back to its original form, and finally I am displaying it to the user. So this is the image. This is all about k-means clustering and how we can implement it using cv2.k-means function. Just quick. So here I have read my image using cv2.imread function. Then I have resized it. After that, this is the whole code that is working. So I am reshaping my image. Then I am converting it into float 30 type. Then this is the criteria, which means when the algorithm will stop working. Then this is the actual code where clustering is happening. And finally, I am converting my image back to its original form so that we can see it. So this is all about k-means clustering. Thank you guys.